Cool. Oh, this is interesting. So I'm gonna share this on online resources. These are the notes that I have here on my tablet, the ones that I'm gonna be following, and it's basically a breakdown of the lesson, or like the lesson by bullet points, basically. If you add Zoom, you should be able to see it. Actually, let me know. We're gonna be using it anyway, so let me just download that.
Hey ho.
Yep.
Don't forget to stream the unit testing.
Yep, that's correct. I'm recording.
Thanks.
Cool. So let's get back here. Can everyone see my screen? Yep. Cool. So testing. What have you heard about testing? Also, wait. Let me see. So to participate, just raise your hand. In physical, I can see everyone. So just raise your hand and speak. Also, I might call on you. I appreciate the people that have the cameras on, so I know that you are with me and I can see you. So yeah, just keep those two things in mind. You can ask questions in the chat. I would like to ask Winter or JR if they could look at the chat for anything that pops up and maybe bring it up. Thank you. Let me make you guys co-hosts, and then we can get started. Cool. Okay, so let's get started. What have you heard about code testing or about unit testing, Douglas?
Does it have anything to do with the debugger in Visual Studio Code, or is that something different?
Good question. It will be something different. It doesn't have anything to do with the debugger. Well, the only thing that it will have to do is it will help us not to use the debugger as much, because we're going to reduce the number of bugs as a whole, because we're going to catch them earlier. But yeah, there's no direct relationship. Others, raise your hand. I can see you. I mean,
I may be wrong, but it's like some functions you write to test your code, and like you input some expected outputs, and it checks those if your function do that, and if yes, it says yes. If no, it says like you're doing something wrong. It's kind of testing your inputs.
Yep. Yeah. So as Amin said, is basically functions that test your functions. So we're gonna be writing code that will test your other code. Joey.
I heard from a good source that it's an important skill to learn as a developer, and we can be asked about it a lot in interviews.
That's correct. Yeah, that's correct. Having unit testing in your pockets when you go to an interview can be a huge asset. So, better to get started. So we're gonna do this into actually three. We're gonna break this into three. Like today, we're gonna see unit testing, which is the most common, the more granular way of testing your code. Then next Saturday, we're gonna see React testing, which is just testing your front end, basically React. And then the Saturday after that, we're gonna learn how to test our backends. We're gonna learn how to test our Express applications. I was trying to fit like unit testing and React testing on this one, but then I realized it was gonna be too long. Context switching was gonna be hard, so I decided to break it down. So today we're gonna learn something about unit testing. So let me pull back here my notes. So the objectives that we have for today is understand why testing is important, familiarize ourselves with the different kind of testing. So we're gonna have a sort of an overview about what different types of testing there are, and be able to use testing and start to thinking about how to test our functions. The idea is that by the end of this testing lessons, you're going to be able to utilize them on your projects, so that you reduce the number of bugs, so that you don't have to check your app manually whenever you change something. So let's talk about then what is testing. I think there were a few good observations. Testing is basically code executing your code. You're gonna write code that will invoke your code with certain inputs, as Amin said, and it's just gonna check that the result is what you expect it to be. And if the result is not what you expect it to be, then you know that there might be a bug, that there's something you need to look into. Also, actually, like, where have you have had experience with unit testing, not doing it, but at least experiencing unit testing? Where is that, Brianna?
The Unit 1 assessment.
The Unit 1 assessment had some tests there. That's a good observation. What else? There is another scenario where you have had dealt with unit testing. Douglas?
Not directly pursuit related, but there was one built in, I believe, to the Etsy test.
As a test, or more generally, coding challenges. When you have done HackerRank, you have done LeetCode, you have done Code Wars. All of those have unit tests, and that's what tells you, 10 of the 15 cases passed, 5 didn't pass. All that, it has unit testing. They give you some samples tests, but they also run some extra tests under that are not public, so that you have to think about the edge cases. So yeah, now we will be able to do that ourselves. In fact, yes, we saw that in Unit 1. And what I did is, one of the exercises we're going to do today is we're going to do 2 exercises of about 20 minutes. 2 first, like doing some examples that we have here in the lesson. And at the end, what I did was I took your Unit 1 assessment, remove all the tests, and now you're going to write those tests for it. And I added like 2 or 3 more questions. The answers they're already there. Your job will be to write the unit tests that verify that for different kinds of inputs, the output is what you expect. Okay, cool. So let's get back. So testing, just code executing other code. Code executing other code for what? For peace of mind. Now, testing is very broad. There is a ton of and testing is broad, and it has a lot of ideas. I feel like I haven't gotten to the bottom of it yet, the way I've gotten to the bottom of other things, just because it's so broad, and sometimes it can be overwhelming about what to test. But it's all about starting small and not letting yourself be overwhelmed, and that's why we're starting with unit testing. There are different, I'll recommend you read blogs online about testing in JavaScript, and testing as a whole. Now, why do we test, or we test for code correctness? We want to check that our code is correct. In fact, there's, for instance, in production environments, when you're working at a company, it's very likely 9 out of 10 that when you make a pull request, they're going to say your code must pass all the tests before we merge your pull request. That's how they make sure. That's how you are going to make sure. That's how the industry makes sure that you have that new code doesn't break things for your users, basically. So any questions on what testing is? Okay. So code executing the code, testing for correctness. Today we'll be looking at a framework called Jest. There are a few frameworks, and Jest is just it's just a set. It's a library. It's a framework that provides us with a way of thinking for how to test our code. It also provides us not only with a way of thinking, but also with some utility functions that we can use to assert that for a given input, we get certain output. And I think it's the most widely used. React uses Jest, for instance. So we're going to be looking into that. Okay, I think we sort of touched on this. What should I test my code? It helps us ensure that when you make changes to a certain area of your app, other areas are not affected, or if they are, then the unit tests will let you know. They will let you know that something broke. For instance, this was yesterday or the day before. I'm building this to-do app, right? And I had changed my login to also take in the user email, for instance. So I changed my auth routes to also include the user email. I ran my test. I ran the auth test, the ones that only test the auth stuff, and those were working. I had to update them to take into account the fact that I needed now an email, and that was running fine. And I committed and I push. Then later on, I merged that into master. Later on, I pull and then I ran all the tests. I wanted to make sure that everything was working. I ran all the tests, and it turns out that about 4 of them were failing. And those that were failing were because I had changed that email in my auth route, but that email was being used on the to-dos route as well, or not the email of when I was trying to register a user to add a to-do to test the functionality of adding a to-do. Then that test was failing because when I was registering that test user, it didn't include the email. So that's like a small example of how you can ensure that when you make changes in your code, you are aware of how that changes other parts of your code as well, or how that influences other parts of your code. And that's something that I call here in my notes, just checking for side effects, checking for a change in your code that might have side effects on other areas. Another reason why it makes you write more maintainable code. The way in which it does that is you're gonna start writing testing code, and you're gonna realize you're gonna have difficulty testing certain functions or certain aspects of your app. And if you're having difficulty testing those areas, what that means is that you probably need to break down the code more in a smaller unit for you to test. So whenever you find that it's hard to test something, it generally means that your thing is too complex. You need to break it down. And that as a whole just makes more maintainable code. Code that has tests, you can refactor really easily, and the test will let you know if it worked. And you can change the implementation, but the test may not change. The test may not need to change if it still produces for the same input the same output. But and the last observation on why, well, it saves us time. You're gonna spend less time debugging manually and checking that everything works manually, and this makes a huge difference. I think now for you, as well as I've realized for myself, as it's sort of compound interest in a way. Like at the first, it's kind of hard to write this unit test, but then they will pay off in the long run, just because instead of having to test everything manually, you can just run. So it's gonna save your time debugging and dealing with problems in your code. Okay, questions or comments about what it is and why? Raise your hand and I can see you. Vanille.
So how do you make sure you write generic tests for all type of cases?
Yeah, so in fact, you don't want to have generic tests, or I'm not sure what you mean by
Like,
generic, but
so
yeah.
for like, if we're working on something specific, like how do you just make the test after? Like, just make sure you're just testing that one thing and that's just is it?
Yeah, but actually there is this thing called TTD, or TDD, test-driven development, where developers oftentimes what they will do, they'll write the test first. They'll write, this function should return a number multiplied by 2, and then they write that test first, and then they write the code. I haven't done a lot of that myself, but I will encourage you, if you're doing, especially for maybe DSA related stuff where you're doing like a problem, try to write the test first and then think of the code. It can help you. It can help you. It's sort of that first step of whiteboarding where you're checking your inputs and outputs, where you're asking clarifying questions. It's sort of the same step, but now in code. Now, I think for the point I think you were hinting at, Neil, we're gonna talk about that when we get into the types of testing, I think. But let me know if later on you still have questions. Cool. Okay, so there are different types of testing. These are the major ones. There is unit tests, integration test, and E2E test. E2E or end-to-end tests. Now, unit tests are what we're going to focus on today. And React will also be unit tests. Once we're testing our backend, we're going to do sort of a mix of integration tests and unit tests. Now, let's talk about unit tests. Well, it's testing the smallest possible unit. In general, the smallest possible unit in your code. And you define what a unit is. In general, a unit can be just a function, just one function. So usually each function you test that. It's an industry standard. As I said earlier, a lot of, I think 90 if not 100% of the companies will ask you to test your code, even write new tests for your code before you make a PR, or make sure that it passes all the pre-existing tests. So it's pretty industry standard. Another thing to remember is unit tests are going to be the most common tests. They are the ones that we have the most in our code bases. And you should have a lot of unit tests. You should have a little bit less of integration tests, and you should have very few end-to-end tests. Now, I think I don't foresee us getting to this point to end-to-end tests. But we'll see as we move along. Maybe we can do that, some of that later on. So unit testing, generally testing the smallest possible unit, usually each function of your code, and you have a lot of these tests. Integration tests, as you know, these are notes that I took basically from the lesson to sort of condense it. Integration test, the purpose of an integration test is verifying the contract between pieces of code. So that is, for instance, an integration test is you have your route middleware, and you have your function that gets all the users from the Dataverse or from your query basically, right? So you have your route middleware that is the one that, let's say, is listening /users. That's going to get you all the users. So that's one function, the route middleware, and then you have your user queries that gets you all the users, right? Integration tests is about checking the contract between those two pieces. Do they work well together, basically? Do these two functions work well together? Do they integrate well? That's why they're called integration tests. They test, they make sure that different pieces of your program work well together. Note here that we're no longer testing one function, we're testing actually two functions, but those two functions might have unit tests individually that you test separately, but then you want to test how they communicate between the two. How do they integrate? And that's an integration test. We're going to be doing some of this when we get onto backend testing. They verify the contract between pieces of code. They make sure that different pieces of your program work well together, and we have less in number. There is not a lot of integration tests, because if you think about it, well, there is, the most common piece of code is like the functions. You're going to have a lot of those, but not all functions communicate with all the other code. Their relationship is a smaller number, and we're going to have less in number. Also, feel free to raise your hand at any point. End-to-end testing, sometimes called system or end-to-end or just E2E testing, is the most expensive kind of test. Also, this is important. I think I'm going to show you a graph in a little bit. Unit tests are very cheap. They run very fast. Integration tests are a little bit more expensive. They take a little bit longer. End-to-end testing, they are the most costly, and they take a lot of time to run. We're going to see a little bit of why. So end-to-end testing is testing done from the end user perspective. So it's, let's say you have your full stack app, and then you test your application. You test the entire thing. You test like the application as a whole, if it's working correctly from the user perspective, like a user logging in, a user adding a new to-do, a user liking a photo, etc. And if you think about it, well, this is sort of the test that we do most commonly, in a way, as without necessarily writing it in code. Like we as developers, we test our code mostly from the user perspective. When you finish a feature in the front end and the back end, you just go in and check if the form works, and you do the submit, and you do all these things. But it's just that those tests that we're doing, they're not automated. End-to-end testing are automated. All these tests are automated. You're not supposed to run them manually, or do the test manually itself. So end-to-end testing is from the user perspective, and most commonly is done with an automated browser. So what you do is you program. There are these two utilities, Cypress and Selenium. These are browsers basically that you can program. So you can see this screenshot here, for instance. It looks exactly like a browser, but here you can write some code that says, okay, when the page loads, go click on this button, and then add this text to this box, and then hit submit. So it's a browser that you can automate, and this will become an end-to-end testing. You're testing your application, across the whole thing. And yesterday when I was taking these notes, I came up with like this drawing here of end-to-end testing. It covers the entire thing, the user front end and back end. Generally done from the user perspective. Like this is the browser. This browser will be simulating a user, and will simulating how a user will use your site, basically. So this is Cypress. Selenium is another one. Yeah, this is it. Selenium Automate browser, that's it. Yeah. Now, okay, so those are end-to-end testing. There's low and less in numbers, even less in numbers. Like you don't want to have a lot of end-to-end testing because they take longer to run. Like if you think about it, like you have to spin up your entire application. Now there is going to be some lag between the user clicking on things or this automated user, and so on. Cool. Any questions about the types of testing? This is a high, this is a high level overview. This is not. Douglas.
What was it was Selenium? Was the site you just showed?
That's correct. It showed these two, Cypress and Selenium.
Thank you.
Mm-hmm. Other questions about the types of testing? Okay. Let's take a look at, so how much you should be testing, how much of each one you should do. There's no right number. Let me start with that. There is no right number about how many unit tests to have, how many integration tests to have. But this is something we had already talked about. Unit tests are small, easiest to write. The most isolated, granular. Integration tests are more comprehensive, cover more ground. Less granular, more likely to and to be harder to change if needed. Yeah, end-to-end tests are they take the longest to run. And there is this article that I recommend that is linked here. Also, if this is not a name that rings a bell yet, make sure to check his website. He is one of the, I guess I don't know if you could call it a guru of software development, but this guy has been in the industry for quite a while, and his blog posts, his articles are the highest quality. So he has this, he has this pyramid here. And these are the same. Like he just call it service test. UI test will be the end of end-to-end test. Service test will be it's the same as integration test and unit test. And we can see here how along this axis, faster and slower, more integration, more isolation. And the pyramid means you should have more unit tests than service test or the integration test, and even more service or integration tests than end-to-end tests. This should be the pyramid in which your applications stand.
I have a question,
Yep.
I guess. I mean, if you write really good test, like really good unit test, or I guess really good integration test, then you technically, I mean, you shouldn't have to run an end-to-end test, because your unit test should catch all your errors. At the end of the day, if an end-to-end test fails, it's because like one particular thing, right? Wouldn't a unit test catch that? That's
a good observation. Yeah, like it's likely that if I have the same pyramid here. So what Michael is suggesting, well, if you have good unit tests and integration tests, then that should catch most of it. Or like, let's say if an end-to-end test fails, that means that there's something that was not done well in an integration test or in a unit test. And that's correct. However, you still want to have, you still should strive to have the three of them. Just because, these two here, integration test and unit test, are very code focused in a way, but the end-to-end test is from the user's perspective. For instance, let's say, I'm trying to come up with an example. Let's say a button in your app doesn't work for a user. Let's say you're doing an end-to-end test where you automated a browser to click on a button to add a new thing. That button might work if you're calling it with a unit or an integration test because you're doing it in code. You're doing, button that click. You're calling the function click on it. But that will be different from when a user clicks on it. Even though, well, I guess it will depend on the specific implementation of the browser, how it calls the click event. But that could be one example where maybe the integration test and the unit test will work, just because it's utilizing your app from the code perspective, and the end-to-end is from the user perspective. But I think I do like the observation you made, Michael, about, well, the more robust you have unit tests and integration tests, the less you need end-to-end tests. You still want to do them, but the less number you need, etc. Another question you might think about is, well, why don't I just write end-to-end testing, and I don't need to do integration tests or unit tests, right? Because end-to-end testing is from the user perspective. I can make sure that the app works for the user, and that's it. The problem with that, then, it becomes that when an end-to-end test fails, the debugging time can still be significant, because it's the entire thing. You have to figure out what was the piece that failed. Was it the front end? Was it the back end? Was it where they communicate between them, etc., where those can be catched in the integration or unit tests, rather. So this is the sort of the testing pyramid: more unit tests, less integration tests, and even lesser end-to-end tests. So keep that in mind. As I said, there's no set numbers, there's no right answer. But you should never have this pyramid inverted, for instance, where you have less unit tests and more integration tests, or end-to-end tests. Other questions or comments? Okay, so let's get some hands-on. Let's do just basic. So cool. So what I want us to do is open up the terminal, and create a folder. Let me see. Can I hide this? How can I hide video panel? Oops. Now all of you disappear. There we go. So let's create a folder called Jesting, I guess. And in this folder, it's empty for now. We're going to create a file. We're going to create a JavaScript file. We're going to install Jest, and we're going to write some functions to it. So let's start by, actually, I'm going to, let's initialize an npm project here. We can do that with npm init-y, the y to accept all the defaults. So that gives me this package JSON. If I do ls, I have that package JSON there. Now after that, what I want to do is I want to install Jest. So Jest is just a node module, npm package, just like Express, just like Axios. What we can do is in npm install. So this is actually the older way, save dev. This is to add our Jest to our dev dependencies. So if you look at this package JSON, we don't have any dependencies, just because we haven't done anything. We could do that as is shown here, npm install save dev, or the same thing which is -d for development Jest. So we install Jest. Takes a little bit. Oh, this is about to die. Okay, so this install Jest. If we take a look at our package JSON, let's do cat backers.json. We should now have these dev dependencies with Jest installed there. Latest version is 25.3. Note how now we have that the dev dependencies. Here we didn't have any dev dependencies. Here's a question: Why is Jest a dev dependency and not a regular dependency? Raise your hand. What other things that do we have as dev dependencies? Chuck.
Because in you only want to be testing your code in your testing environment. You don't want code that is not suited. You don't want code that is testing code to be in the environment you have your users in.
I think that's close. I think it could be a little bit more accurate. Let's see here a few other options. Joanne.
I was gonna say node one.
Node one is another dev dependency. That's correct. And why are those the dev dependencies and not regular dependencies? What do you think?
Is it because you don't necessarily need it?
Exactly, right? Because our code will work without node1. Our code, like our application, will work without node1. It just needs node. Same thing here. Our code will work without Jest. Jest is a development dependency for us to, when we're in development, test our code. That's the same reason why. So that's why we install it in dev dependencies, not in the regular dependencies. So our code does not depend on Jest to run and to work. It's a development dependency. Cool. So we have installed Jest. If we look at ls, we now have that no modules. Inside of there's Jest. The next thing that we're going to do is we're going to create a functions file. So I'm going to do touch functions.js. So, oops, the touch functions.js. And I'm just going to open this entire folder with VS Code. Let me put this here. Oops. Let me change this to a white theme so that it's easier to see. So we have our functions file here. And then we're gonna say, okay, let's say we have a function multiply by 2. So I'm gonna do this in ES6. Let's say multiply. So a function that takes two numbers, A and B. And it returns A times B. The next thing that we want to do is we want to export this function. We're going to export, this is, you do this all the time with React and Express. You export things to import somewhere else and use somewhere else. So let's export this multiply function. Okay, so we have our multiply function. Now we want to test this function. Generally what we'll do is we'll do console log multiply, 2 times 4, and maybe a few more to check what we have. And then we'll run our code, right? We'll open terminal and we'll say node functions JS, and then we'll check, oh, okay, 2 times 4 is that 8, that's correct. 0 times 4, 0, 1 times 1, 1, 6 times 120, 720. And then we'll move on. Like we'll just test with a console log, we'll move on. But then we are the ones that are having to do the sort of these calculations, checking if it's correct, right? The idea is we're gonna get rid of this. Like we're gonna write some other code that will do it for us. So I'm gonna take this out. Now the next thing then is we need to create a test file. So generally test files are just named the same as the original file, but instead of .js is .test.js. So same name as your file, but .test.js at the end. And you can see here that VS Code colors them in a different logo. And that's it. Now in here, we're gonna write our first test. So let's take a look at this. Now what we do here is we need to import our function from our file. So let's do const. I'm gonna call it f functions. Let's say functions equal require current folder. Actually, let me reduce this size a little bit. Current folder functions file, and then here I can use my functions. Oh, actually, I'm gonna abbreviate this to FNS for functions. So we have our functions there, and then here we could call it. We could call fns.multiply. Right now we just have one. Remember, this is what we're exporting from our functions.js. We're exporting an object that has a multiply function in it. This whole object we're going to call the functions object, and we're going to call the multiply function. So we import the functions object as a whole, and we call the multiply. So here we could call multiply like that. But instead of just calling it like that, we're going to write a test for it. So the way in which you do that is there is this function called test. And here, the first argument to this function, to the test function, you pass on 2 arguments. One is a string describing what the test is about. The second argument is a function that actually contains your test. So here we're going to say, well, multiplies 2 numbers. 2 numbers. This is what the test is about. I want to check that my function multiplies 2 numbers. Question, I mean.
Yes, is test part of Node?
Good question. Where is this test function coming from, right? If we think about, for instance, the first function you probably saw in JavaScript was the console log. Console was one of the first JavaScript lands that you've seen. And we think of console log as is ever present. Like it doesn't matter what you call it. You don't have to import it. You just use it, right? Test is similar, but console log is for Node. Any JavaScript, actually not only Node, any JavaScript code will always have in the global context, in the global scope, a console object, right, available that you can call the log function on. Test is a global function that will be made available to our test file by Jest. So test does not come from Node. It doesn't come with React or anything like that. It comes from Jest. We don't have to import it. Because we're gonna call, because of the way in which we're gonna call this file. We're gonna see that in a second. But test is a function that is globally available thanks to Jest. It comes from Jest. So test function, and then the second argument is a function. So it takes in a callback. First argument, a string, second argument, a callback. Now here we can say expect. Expect is another function, comes from Jest 2, globally available thanks to Jest. And here we can say, okay, expect multiply 10 times 2. Just say it like that. Expect this, and then we can say to be 20. This is the cool thing about testing, and especially with Jest. It reads almost English-like. Expect multiply 10 times 2 to be 20. And we're going to talk a little bit about what this to be is and the expect. So here we're saying, well, expect that if I call this multiply function with 10 and 2, the result should be 20. You could also do this, like instead of doing it here, you could say let result equal that, and then here we can say expect result to be 20. There's no.
Alejo, you don't have to do fns.multiply.
Oh, great catch. Yes, I need to do fns.multiply because I'm calling that. I could also, well, we could also destructure. You know what? Let's destructure here. Let's destructure multiply here. Yeah, that looks a little bit better. Thank you, Peter. I think the way we were doing it here, what was the way that we were doing it here? Oh, here, look at the way that we're doing it here. We're just saying require functions, but I'm only interested in the multiply key. And we say that to the multiply. Here, we use this structuring very often in React. We can use it here. Okay, any questions up until this point? So we have our first test. The question is, how do you run this test? So you could think, well, we could just call that with node like this. But if we do that, then we get the following. We get test is not defined. Because again, I said test is not a function that is in node, it's in Jest. So somehow Jest needs to be in context. So we can't run it with node. What we can do is we're going to run it with Jest. Just Jest instead of node. And now for me, I'm getting this command not found. Raise your hand if you're getting this command not found.
I tried npm run test.
Yep, that's what we're gonna do next. If this Jest doesn't work for me here right now, just because I don't have Jest global install. I only have it in my node modules. So anyway, the best way to test this or to run that test is you go to your package.json. And do you remember the start script? Oh, why can't I close this? Oh, there we go. If you go to our package.json, you see when we have, this is our package.json for this project. Generally, you have here a start method, start property that is like nodemon. This is if this was an Express site, nodemon bean www something like that, right? We have some scripts here. We can add our own scripts, but for this, what we need to do is do test. This test script, just the way we do npm start and it runs the start script, we're going to do npm test and it's going to run the test script. Now, right now we don't have any. This doesn't do anything. If we do npm test, we get this error no test specified, which is literally what it says here, and exit with code 1. Instead of that, I'm going to change it. Instead of having that here, we're just going to write Jest. So that when we do npm test, it runs with Jest. So now, once we have that test there, we can do npm test and cross our fingers that this will run. Great. Now we have our test here. This is the output of our test that it ran with Jest. We got a green pass, meaning our function has passed the test. Questions or thoughts up until this point?
Did anyone else get failed?
Say that again? Oh, anyone else got fail? Okay, I see one, Kathy, Suzette, and Ansa. Kathy, what do you see in here?
I got test suites 1 failed and test 1 failed.
Okay. Do you see any like error message popping up, or just it just says it failed?
Oh, okay.
I think it says something around 2B.
Yeah, it says to be is not a function.
Oh, I see.
Oh, it's because B is a capital. Like
B,
capitalized?
yeah, capital B here.
Okay.
So check your spelling. Spelling mistakes. There is no unit test against spelling mistakes.
Yeah,
Well,
that works. Okay. Ugh.
So that worked for you, Cameron?
Yeah.
Kathy?
Hmm?
You work too?
Yeah.
Cool. Suzette?
It still says failed.
Let's take a look. You want to share your screen?
Hold on. Wait. Can you show your code again?
Oh, sure. You're checking.
I think I fixed it. Yeah. I had like an extra parentheses. Yeah, it works.
Oh, great. Cool. Any other questions that you have? So let's go Owen and then Amin.
Sorry. Could we do multiple expects in one test function?
Great question. Yes, we can do
And
multiple.
Can you hear me?
Yep.
Hello?
I can hear you well. Can you hear me?
Oh, wait. Okay, sorry. My thing was frozen for a second.
So
oh yeah, so my question.
Keep going.
Oh, no, my question was, can you do multiple expects in a test function, and also like, does this work like how promise works? Well, actually, maybe not. That's a dumb question.
I think I know what you mean about like synchronously versus asynchronously.
Yeah. Can you do can you do tests asynchronously?
That's correct. Yeah, that's a very good question. Yes, we can test asynchronously. We can test if a promise resolves after some time to a given value. Maybe we can, not sure we will get to that point. Just because that, like when you're doing asynchronous stuff, well, actually it can be a unit test still. But yeah, those are very good point. Very good 2 points that we're gonna get to explore one, which is the multiple expects. I'm not sure we're gonna get to test something asynchronous. I think we could do that as well. I mean, you had a question.
Yes, just like why it didn't work when you did in the terminal just and it worked with the tests, knowing like the script just run what you have as a value.
Yeah, it's just because when we do npm test, npm will look first at the node modules, and if it finds Jest there, it's going to execute it from there. When I do just Jest, there's nothing looking in the inside of my node modules. Just when I type in Jest, it's going to look into where my executables are, and Jest is not there. And does that make sense?
So the script looks inside like the global ones, but if it doesn't find it, it checks the dependencies as well. This is
no, the opposite. This one checks this test Jest will check in the node modules. So you see in the node modules we have Jest here somewhere. Jest here. So this one will check in the node modules first. When I type it in my terminal, this is not checking in the node modules, in the local node modules. It's looking in the global node modules, and I don't have Jest there. It's a good idea to have it install globally, so I'm going to actually do it. Let's install Jest globally. Just do Jest. Oh, not Jest, npm. And then if I install it globally, then I can call it anywhere. But you know, it's better to just do npm test every time. Set up your test like we did here with the test script. And if I do it just now, then it works. Great. So we have our first Jest test passing. Let's take a look. I'm going to close the package.json. Right, so we saw that working. Oh, we changed this. We saw it passing. And you know, this is the basic idea behind testing. We write code that verifies that our program is doing instead of us manually doing it with the console logs. Now let's take a look at this. So what happens if I go to my multiply function? Actually, I shouldn't do it to do that. What happens if I go to my multiply function and I have a, b, just return 20? Run your test again.
It still passes.
Still passes. Should it pass?
Only for this case and any other case where the answer is 20, but that's about it.
That's about it. So that's been, you know, this is sort of going back to what Owen mentioned. Well, we want to make a few expectations. We want to expect a few different inputs. One is just not enough because, you know, somebody goes in the code and just change the result to 20 and then our test will still pass. So what we can do is just make sure that this actually is multiplying with a few more expects. So let's see, so that's that. Let's do, so I'm gonna remove the result. That's just to show you there. I'm gonna write it directly here. Expect that to be 20. I'm gonna copy that line and I'm gonna try another one. Expect this to be 25. So we do add another expectation there. Now run your test again. Now we see that multiplies two numbers fail. And we can see here, this output is, you're gonna be looking at this often. Says fail, multiply two numbers, then it tells you this expect received, and this is the most helpful part. Expected 25, but it received 20. And it also points to the line number 5, and it shows you this thing here, to where it is your expectation that fail. This one passed, that one doesn't complain about it, but the second one failed. So this second expectation that we have then, you know, guarantee us that then we can't really just do 20. Now we have enhanced our tests to make sure. So now we do A and B. Again, with A times B, the correct one, we no longer have hard-coded 20. We run our tests. Oops, npm test. We run that and we have it passing, one test passing. That our multiplies two numbers is passing. Cool. Write two more expectations for this multiply function.
So Alejo, I have a question.
Yep.
Where it says one test pass, because I did 3 of them, does that just mean like the general test function and not like each expect?
Correct. Yes. Correct. A test is made of expectations inside. Yeah, but when you have this number of tests here, one test passed is one test function.
Okay, thanks.
Your test should always have a few expectations. Never only one. One expectation is not enough. So write 2 more expectations for this example here. And then give me a yes on the nonverbals once you are done with that. Okay. A question I had for you is where do you have that yes button? Where is it in like the lower bar? Where lower on the video, or where do you have the yes button?
Like in the participants thing?
Oh, it's in the participants tab?
Yeah, if you go to participants and then below like everyone's name, there's a few options.
Got it. Okay. Yeah. Yeah, so it's the same as me, I guess. Cool. Thank you, everyone. Let's see. Aranza, do you want to share what you have? What other expectations you added? Oops, I think we're not hearing you.
Can I just tell you them? I just added 6 times 6, so expect multiply 6 times 6 to be 36. And the next one, 7 times 7.
Okay.
And then it's to be 49.
Cool. Let's run our tests. Thank you. Okay, cool. We have our test still passing. Wait, so you can think of in TDD, test-driven development, people write this first, and then they write the function. And that's pretty much it. Now, I think here in the test, you want to sort of think as,
I was about to say, like, also it's better to put like some edge cases or things like you expect to break your code. I believe
Correct. I think that's where I was going to go next. So I'm glad you brought it up. You want to test. You want to think of sort of edge cases, as Amin said, that could break your code. So, for instance, we said, say multiplying by 0, multiplying by a negative number, multiplying both negative numbers. What's another edge case? Let's say
text times.
Oh yeah, I think that was. Do we have to do that test? Maybe we didn't include that test. 1 times 2. But this one will probably write in another test, because this test is supposed to check that it multiplies two numbers. Here we want to check what happens when one of the arguments is not a number. For this, we'll write a separate test. So it will be something like test. Let's say returns null when one of its arguments is not a number. Because right now, I think right now is going to give us a few weird results. If we pass the string 1, then we might get the string. We're going to get this string. So let's do this one actually. So let's say returns null when one of the arguments is not a number. So what we will expect here is something like this: expect multiply hello times 7 to be null. So this test here is testing that it multiplies two numbers. If you pass on numbers, you get what you expect. Here we're gonna do another test to check that when one of the arguments is not a number, it should return null. By a show of thumbs, is this going to pass or is it going to fail? Thumbs up if it's going to pass, thumbs down if it's going to fail. Okay, I think thumb down is winning. Any argument for that?
It's gonna be none.
None, yes.
It's gonna be none, right? What happens when you multiply, when you do some math on something that's not a number, you get NaN, not a number. So if we do this npm test, we get, so here, look at this. Say this first test pass, our multiplication is passing. So when we pass on the numbers, that works perfectly. But the second is not passing. Returns null when one of the arguments is not a number. Also, very important here, this string, you want to be descriptive like this, because that's what that's what is going to show up here for you to know what test is failing. So here we received nan, we were expecting null. How could we change our functions so that it returns null if one of the arguments is not a number?
You could have a conditional.
Have a conditional. What kind of conditional? If
one of the if A or B, well, if A is not a number.
How do I say is not a number?
Oh, if A does not equal. Oh wait, no. Oh, if not a number A.
Oops, wait, what's this? If, well, how do I say that in code?
Oh, it's NaN, and then parentheses A.
Oh, this? Like that?
Yeah,
you're saying like this?
Yeah.
I think 9 is technically a number.
Yeah.
Oh, right.
That's the most confusing thing about, one of the most confusing things about JavaScript, the NaN.
I think you have to use isNaN.
IsnAN, yeah.
Can't you do if
we can't even use isNaN. No, we're not gonna use isNaN here.
Can you do if A is greater than 0?
Oh, that could be one, but then negative numbers are still valid.
Then I'm out of guesses.
What about, do you remember unary operators?
No.
Equals number.
Unary operators. Say that again, Joey.
Type of equals number.
Type of equals number. That's correct. Unary operator. So if we can say if type of A is not a number, is not number, is not number, or let me add it here. Type of B is not number, then return Let's try this again. Oh, and here actually we ended up doing our first test-driven development. We wrote the test first, and then we wrote the code. Let's take a look. PM test. No, it passes. So that's all. That's test-driven development. You write the test first. None of them will pass. Then you write the code that passes the test. Now let's do a few other examples. So that's if that's there. Joey, I see you have your hand raised. Give me 1 sec. Let's put the second argument to second by. You know, run that again. It should pass. Cool, Joey.
Yeah, just curious. Why didn't we want to use isNan?
Because isNan checks for nan. So here, let's deviate a little bit and go back to node basics. If we say isNan, and we say 1, we get false. This is a number, right? 100 is a number, we get false. Because so this gets a little bit weird. 100 is a number. 100 is not a number. It's not a number, right? Because 100 is a number. isNan only work. It's only helpful for checking for nan values. True. So for instance, if we do this, let's say hello times 3. Oh, I didn't know that Node had this REPL thing that already evaluates without hitting enter. Because this multiplication, hello times 7, gives us nan. It literally gives us this 9. And we can just check if that is nan with the isNan function. That gives us
Oh, it doesn't work for strings either.
So if we say
put
this,
like isNan 100.
So wait. Now, so it gives us true because hello is not a number.
But if you put the number 100, it won't work. It'll say false.
Yep. That's the detail there. So the thing is nan. So this is thanks to the flexibility of JavaScript that does data types coercions, data types conversion automatically. The thing is nan has a quirk to it. The problem with that is that isNan will take in anything that is passed to its argument and it will try to convert it to a number. If it converts it to a number successfully, or if the coercion returns a number, the conversion returns a number, then isNan will return false, like in this case, because the string 100, can be converted to a number, and the number is 100. A number is not a number. I think, let's see. Yeah, now if we add a little bit of other stuff, then that cannot be converted. So isNan can't really help us here, because if we pass a string, that's not a number. then it will do the automatic conversion. There's another isNaN, that is the one in number, that isNaN, which makes everything even more confusing. Oh wait, no, this, yeah. Still give us, it still give us that 100 is not a number. There is a difference between isNaN, the global isNaN, and the number isNaN. Yeah, so you see, for instance, that the number isNaN, if we pass in hello, it gives us false. The global isNaN, if we pass in hello, it gives true. There is some differences that are worth noting. We can't really get into it right now, but that's why we couldn't use the isNaN. Better to use a type of. So we have this, and our tests are passing. Questions, comments, or thoughts?
Is there any way to just as like a matrix of the values instead of like writing the function out each time?
You mean like, I think I know what you mean. Like, you see how we're doing this multiply here? Basically a way to not have to call the function manually, sort of how we're doing it here. And
yeah, kind of just like put it in a loop and it runs through all the results. Yeah,
no, that can be done. I think I've noticed this way of thinking in you a few times in the past as well. This is good. Trying to remove repetition as much as possible. I think the one that we set in for the Unit 1 assessment, which was it was not using Jest, it was using like its own custom thing that Ben did. It uses something like that. You should check it out. But well, that one is not using Jest. It's just using the built-in into Node. Node has a few built-in expectation utilities. Cool. So let's take, let's see. Let's take a 5-minute break. Grab water, stretch before we get into this exercise. Let's be back here at 12. No, not 12. I'm so bad with numbers. You know what? Let's take 7 minutes. Let's be back here at 11:35. 11:35. Need to fill out my water. Okay, welcome back. Oh, I realized Zoom changed something in their interface that I don't like, which is now I can see if I'm muted. Like I have to look at, like before I could see if I was muted or any one of you was muted by looking at your images at the bottom will appear like the cross microphone. They removed that, and now I don't know if you are muted or not unless I hover over your picture. Oh, I guess like, oh, I see. I have it also in the participants tab. Okay. I guess now I have to look at the participants tab to see if you're muted or not. Cool. Let's get back into this. So I think, so, so we did. I didn't realize that we basically answer one of the points here, which is returns null when either one of the parameters passes not a number. But I want you to, so what I want you to do is like maybe 10, 15 minutes is go to, if you're running the lesson, go to the using matchers and expect reference. You can share this here in this chat. There should be a shortcut for the chat. Everyone, share that there. Share this here. Take 10 minutes reading over there, or spend 5 to 7 minutes, read through the user matchings guide, and just read through it and see what you find and learn over there. And then after that, we can look into how could we do this one. So Okay, so what did you find out? What did you learn? Raise your hand, I can see you. Cameron.
There's more than just to be. You can actually have things that like to be defined or to be truthy, like have more functionality with that. So you can have better tests, I think.
So we have to be. What was the other one you mentioned?
There's to be no, to be defined, not that to be undefined, not that to be truthy. Like different variations of that, it seems, but not and to be falsy.
That's correct. So these are known as matchers, basically. And this is what is going to help you make assertions. There is a whole ton. I recommend you explore the documentation on Jest. This also, to be nan, for instance, to be undefined, to contain a whole ton of them for you to better describe your expectations. So now, I want us to take another 5 minutes to write a test for this. Write another test case. So this test case that we wrote here is like the second part of this, returns null when either or one of the parameters is not a number. How would you write a test for this? Let's take 5 minutes. Write another test in your test file for testing for this. Testing that your function always returns something. Never returns undefined. Give me a yes once you're done. Cool. I see some of you. Let's see. Let's go, Cameron. Let's do. Can you show your screen? Show
Sure.
us what you did. Let me. I think I have to stop mine. Oh, did I stop mine already?
Nope. I can try to stop it. Oh.
It says it's not gonna let you, right?
Yep. Let me.
Oh, I need to learn the shortcuts for this. So view, show floating controls, stop share. You can go ahead.
Okay. All right. So just have this really. It passes. Well, actually, I didn't run anything. Boom, boom, boom. Oh, so this one's actually failing.
Let's take a look at where it fails.
Yeah.
Oh, this is. Scroll up. Scroll up.
Oh, this is why. This is not in there.
Mm-hmm. Okay.
Silly. Okay, that's better.
Cool. Yeah. So, do you want to tell us about this?
Basically, all it seems to be is just like a third check after you do your other checks to make sure, or maybe you can do this in the first, but you just want to make sure that there's something coming through from the functions side of it.
That's correct.
And yeah.
So the method you use is to be defined. That's great. Now, also, this makes me think about something that I forgot, which I think is worth mentioning right now, where you see how Cameron has the results variables, right? And he calls it function. This is the same thing that we were doing, but something that you should never do is, and he's not doing it here, but I thought for a second he was doing it, is you should never share state between tests, or at least not for unit tests. We're gonna do some of that for integration tests, but you should never share state for unit tests. What do I mean by that? He could have done, let's say, the line 22 to line 25. Let's say those lines are all the way at the top in the global scope. And then in the test, he just does expecting the results, right? That will be wrong because that we don't want to share those variables among tests. For the most part, we don't want to share anything among tests. We just want to do the recalculations, basically. So if, for instance, Cameron takes line 22 to line 25, and he puts them outside of the test block in the global scope and just reuses it throughout, that will not be a good practice. So when you're doing tests, you shouldn't have anything in the global scope. We're gonna see that there are some cases where that is allowed or necessary, but think twice before you try to share variables or state in between tests. Cool. So thank you, Cameron. Who used another different matcher? So Cameron used to be defined. Douglas.
I had actually used a knot. Here, let me see if I can share my screen. Hold on one second.
Let's take a look at that. Yeah. Oh, also Cameron, you should also include a few of the other test cases with like numbers or stuff like that. Not numbers, strings. I mean.
Oh, okay.
I think you had all of them with just the numbers.
Right.
So let's take a look at this. Oh, cool. So tell us about this, Douglas. Oh, I think we can't hear you.
There we go. Sorry, I couldn't find my controls at first.
That's fine.
Let me head back to my code so now I can see everything. My idea was to try to specifically have it trip over things that we had in our functions, because again, if it's not a number, it should always return null. So with that in mind, I figured, okay, so if we're trying to multiply an array by an object, we don't want it to be defined or to be undefined. So it should return. I mean, I could have also done to be defined here rather than doing a negative, but I think I completely overthought this. But
oh, this is fine. This is fine. I actually am glad you're showing us this, because yeah, you could use the negation dot not for doing this as well, and it's perfectly fine. At some point, it will be which one. If I say it, which way does it make more sense, or is more easy to understand? I think in this case, I think this is actually better, because we're actually specifying that it never returns undefined, and your test is expect this not to be undefined. So it becomes a little bit of a personal preference at some point. But this is great, yeah. Make sure that also include a few more expectations, so that it's just not only one. One expectation is never enough. Cool, thank you for sharing, you too, Cameron. That was cool. So let me share back my screen. Okay, cool. Great. So then let's actually do that one here. Say test. Function never returns undefined. And then let's expect this too. To not be undefined. Close this. To not be undefined. Note here that there are matches to which you pass an argument, like to be. There are others that you don't have to pass an argument, like to be undefined, for instance. To be undefined. To not be undefined. Let's try 0 times 1. 2 times 1. To not be undefined. Let's test our code, npm test. Great, function never returns undefined. Wait, even if we pass nothing, it should return no, because the two arguments are undefined. They are not of type number. Awesome. Questions, thoughts about this? Everything clear so far? Great. Cool. So let's then take a look at the last thing, which is grouping test cases. So what we're gonna do is I'm gonna go back to my functions. Let me hide this. Let me try to remember this shortcut. Oh, I think I got it. Oh, great. So I got a new shortcut to hide the controllers. Then let's do this. I'm gonna go to my functions file. And we're gonna write this other function. I'm gonna take this from here. Square an array. Let's do this in ES6. Just because we're doing ES6 stuff here. Now, we did this last week. Well, last week that we did we did array methods review. What does this function do? Square array function. What does it mean to square an array? I mean,
it squares each element of the array.
Okay, so if I pass in an array with 1, 2, 3, what am I going to get back?
1, 4, and 9.
This is the return value, right? Cool. So this function squares an array with a map. Right? This V stands for value. Yeah, let's just leave it like that. And it just returns that. It returns that new array with the square elements. For each element, it's just going to multiply each element by itself. Great. So we have a new function. And we would like to write some tests for this one. I'll also never forget to export it. So we have a few functions. Let's save this. Now we want to test it here. Now the thing is, the tests that we had before, they were all for the multiply function. And now we want to test the square array function. We could just do another test here for the square array function, but then it's better to start grouping things together. For that, what we're going to do is we're going to use a describe block like this. So describe block is just to group tests. It doesn't have any special effect from there. You see how I think I'm not sure on this, but I think we're going to see those. The describe are what are going to be test suits. But let me double check on that because I don't remember exactly. So what I'm going to do here is I'm going to do describe. Describe is a function that comes from Jest, not in Node. The first argument is what are you describing, basically. And we're describing the multiply function. Multiply. So I'm going to say that, say the multiply function. The second argument is a callback function like this. Just same arguments as a test. Now what I'm going to do is we're going to move the test inside of the describe. So I'm going to take these two, remove them, and put them all the way at the bottom like that. Save that. Indentation kicks in. Let me show you what this looks like in a smaller zoom. So we have describe that describes the multiply function, and we have three tests for the multiply function. The tests are inside of the describe. That is important to remember. The tests are inside of the describe. And all the tests, are inside of the callback function, just like that. Okay, so we did that, and if we run our tests, npm test, then we get this new thing here that is the multiply function, and then these are the tests within that test suite, within that describe. So describe is just used to group tests together, to group tests by the thing that you're testing. Here we have three tests for the multiply function, that it multiplies numbers, that it returns null for stuff that is not a number, and that it always returns something. Those are three tests that are belonging to the multiply function. We wrap those in a describe. Here we're going to do the same thing. Actually, I'm just going to copy this, and you're going to do this. This is the second exercise. So I'm going to put the describe here. Square an array. And well, I could, let's just do it like this. So here we're going to describe the square an array function, and we're going to write 4 tests for that function. We're going to check that it rejects for non-arrays, or that it returns null, rather. That it returns an array. It should not return a number, for instance. That it returns an array that is the same length as the one that was passed in, and that it returns the right value. that returns, I think here, right, value returns a square or an array where each element is square. I'm gonna share this in the code share channel, so you have it and you don't have to type it. Code share. So I just shared it in the code share channel, and then let's take 20 minutes to work on this. Feel free to ask me any questions at any point. Now, here you're gonna need to look into this. Here's a couple matches that you may find useful. The instance of to be to equal. Also, you want to take a look in the documentation. What's the difference between to be and to equal? Read both. See what the difference is. So let's take 20 minutes to do this. Actually, let's do the first one. Let's do it one at a time. Let's do the first one first. Give me a yes once you have that one, and we can review it immediately and move on to the next one. Cool. So let's take a look at the first one. You're gonna have a chance to practice a little bit more on the unit test lab, which is small. We should maybe, yeah, we can take after once we're done here. Once we're looking at this, take the rest until 1 to work on this. It's a small lab, more practice. Hupo, do you want to share what you put in for the first one? Oh, you could just tell me, but I think we can't hear you right now.
Can you hear me now?
Yep.
Yeah, so I just put like for each of the tests, for one I put like a number and then some text and then an object, and then for the
so tell me what to type. Tell me what to type.
Oh, I just put expect square array and then like 5 in the parentheses, and I just put to be null.
Oh, you did this?
No, I did the one where it's nulls in the parentheses.
Got it. Okay. Yeah. So those both are acceptable. You can say to be null. I think there's another one which is just this.
Yeah, literally just to be null. Yeah.
So there are some predefined, but they both are the same. Do the same thing. So okay. So you did this one. What else?
And then the same thing with just like text in like quotes. Yeah. And then another one with just like an object with one key value pair.
Object key value.
Yeah.
Yeah, I think these are good examples. Let's try to run the test. npm test.
Oh, you have to put the test in the functions.
Say that again.
You have to put the conditional in the functions JS.
Oh, right.
So
I have
it
to
can
modify
return.
it. I have to modify it. Let me see. To the test suites. Okay, no. So we see that the multiply function is still passing. That still runs. The square array. Oh, look at this. We're passing all these tests. Returns an array. Returns, but that's just because we don't have expectations over there. This one is This one is not passing. Let's take a look at what it says here. Rejects non-array, returns null. Reference error. Square array is not defined. What does that mean?
Oh, it's import it at the top.
Imported here at the top.
Yeah.
Square. Oops, that's Sudan. Square array. Did I call it like that? Square array. Yeah, I did.
Yeah.
Let me hide this thing. Square array like that. Let's see. So let's try to run it now. npm test. Now that I'm importing, we see another pass. Now we get this error. Array map is not a function. Array map is not a function. That can be a little bit confusing. Why is it saying that array map is not a function? And it's pointed to line 14. Any clue?
Oh, because what it's receiving is not an array.
That's correct. So what we pass here in our first expectation is a 5, and we're trying to do 5.map. That's not a, our numbers don't have map. Correct. So then, Hupo, you said we need to modify functions to make this work. So why do I need to change here in the square array?
Well, so I just put a if statement that says if type of array is not equal to array.
Oh, you said if type of array is not equal to array, like that?
Yeah.
Okay, let's take a look at this. So if that's not true, what do I do?
And return null.
Return null. I mean, I saw your hand. Let's take a look at this. There's something wrong around here. We're gonna take a look in a bit. Let's see if that changed anything in our test. PM test. Okay, that passed there. But it's passing. It's passing because of this condition, but this condition is wrong. We need to take a look at this. So this is actually something you're gonna find where you're gonna come up with a test or you're gonna change your code and you're gonna think that it's working, but it's just that we're not testing hard enough or we have a mistake in our code. Here, it says that it's passing, but do we have a type of array though? What are we gonna get? We say node. Let's say let ARR, and we have 2 and 3, just 1 and 2. Oops, forgot the equal. Node. If we say type of array, we get object. I mean, was this what you were going to point out? Right. So there is no type of array, right? Okay. How can you tell if something is an array or something is an object? I mean,
you do array dot is array.
That's correct. We can say array that is array, which is, we can say array from the constructor function for arrays that is array, and we pass in ARR, we get true. So this is how we can tell whether something is an array. Type of works for an array is going to say object. Type of is more for primitives. But if you want to, everything that's not a primitive, just an object. Now, that's one way. We could also use this option here to be instance of. This is one of the matchers that we have. Let's take a look at here. Command F to be instance of. So used to be instance of class to check that an object is an instance of a class. This matcher uses instance of underneath. That is another way in which we could do. We can say array, there are instance of array, true. This is another operator that we have, instance of. We could do it in the matcher as well. Okay, so then let's use, array, let's use array that is array. If we pass in a number, get false. If we pass in a string, get false. If we pass anything that is not an array, we're gonna get false. So that is the right condition that we need to do here. Also, before we move into there, let's see why this was working. So this was working because type of array return object. We saw that here. Type of array return the string object. Object is not array. Object is not array, then it's gonna return null. In fact, if we had written more test cases, more expectations, we'll realize our mistake, because once we pass an array, it's still gonna return null, because type of ARR here returns object, never gonna return an array. So that's sort of another reason why you wanna put more expectations. So let's do that here. Array that is array, ARR. So if that is true, if that is not true, return null. Let's take a look back at our code here. Let me put this on the side. Let's test, npm test. Rejects non-arrays, return null. This is our case here. These are our 3 test cases. Let's pass in like a Boolean, true. Okay, cool. Anybody else wants to share this option, returns an array? All right, let's take, actually, I think we're running a kind of short on time, and I want you to get to the other exercises. Anyone wants to share how they will do this one? How to test that it returns an array when the array is passed. Douglas.
Could we use the instance of qualifier that we just learned about?
Mm-hmm. We can use the instance of. We could also use the matcher, be instance of, that we have here. I'm gonna close the functions because I don't think we need it anymore. Transfer a new array. So if we pass in, let's do expect square array, and we pass an array with 1 element. Let's expect it to return to be instance of array. This is how we would use the matcher, right? Let's try this. Let's make it fail first. It's often let's make it fail if we do a string. So npm test. Cool. We can see here square array. That passed, no, didn't pass. Expected constructor string, received constructor array. So this is my test was expecting string, but it received an array. The constructor I want to use is array. So we can use that. Another way of saying now our test passes. Another way of saying this is with the instance of. We can say expect this, pass in another 2. Let's see, we could do this. No, but this is the best way, to be honest. The other way will be instance, not instance of. Yeah, actually instance of. Instance. Sorry. Oh, actually, I'm having trouble converting this to the one that we had before. Expect.
Can you do array that is array for this one?
We could do array that is array. Let's do that one. Array that is array. It will look something like this. To be true. We're doing the same. We're asking the same question. Expect. Do I have extra parentheses that I don't need? Let's try that. Oh, that failed. Arrays. Oh, I have a spelling mistake here. Array that is array. So we can expect that this is going to be true, right? That's another way of saying the same thing. I was trying to come up with the other one where we have instance of. Oh, I know now. It will be something like this. Instance array. Say this. Instead of array to be true. We expect this to return something that is an instance of an array, that is an array, to be true. Another qualifier that Cameron mentioned earlier or mentioned, truthy. Now with truthy, well, it depends on what you're asserting, but if you pass in a 1, that's a truthy. If you pass in a string that is not empty, that's a truthy. If you pass an object, a square bracket, that's truthy. Here, cool. So we have that returns. This is basically these 3 tests. Actually, these 2 tests are not very meaningful because they're just saying the same. They're asking the same question, giving also the same inputs. Let's do from here. I'd say the preferred way will be just use this custom matcher. So even if it's an empty array, it should still return an array. Great. Cool. So we have that one. Returns an array that's the same length as the one passed. How could we check for this one? Let's see. Vonil, what do you think? I think you're muted.
Returns an array that's the same length of the one pass. It could be check the length of both.
That's correct.
Boolean.
So how could we write that expectation?
Could pass in whatever array you pass in. So like say if it's 2, 1, could be 2, 1 dot length. Dot length.
So dot length here?
For yeah, to be to equal. The same array dot length.
So it will be 2 in this case.
Yeah, 2.
But here we have a few mistakes here. One is here we will be passing in a number to our square array. So we need to pass the array. So if we do, we can't really do this here. What we could do is, so actually, anyone wants to share the difference between to be and to equal? Did anyone find the difference between to be and to equal? Raise your hand. In physical, I can see you. Joy.
When you compare objects with each other, the two objects can never be the same. So when you want to compare two arrays, if they're the same, you want to use to equal, because it won't check if they're the exact same object. It'll check more if they have the same values inside.
Right, exactly. To equal is used for non-primitive, for objects and arrays. Yeah, objects and arrays. I think even for strings to be will still work. To equal, as Joey said, it will check the value. It will check if the values are the same if we have an array. It will check if the keys and the values are the same if we pass in an object. To be is more like the triple equal. To equal is going to go inside of the object, inside of both objects, check that they have the same keys, check that they have the same values. We're gonna do that a little bit. We're gonna do that in here. So here, better to do that length. No, not that length. Sorry. To be. Now, what we can do here is we want to check that this is the same length as the one that we passed in. So what we could do is here. Let's say input 1 equal this. And we pass in input 1 here. And we can say input 1. So we know that this part will return, an array, say that length on that array to be equal to input 1.length. So the result of calling square array input 1 returns an array. We want to make sure that the length of that is equal to the length of the original element. So let's take a look. So actually, before we do that, I always like to see it failing first. So let's say it to be 0. Let's expect the length to be 0. Test. One of them should fail. Here, returns an array that's the same length as the one passed. Fail because it expected 0. It received 2. No, the length is 2. I did this on purpose where I expected it to be 0. Expect it to be 2. This is a good technique to get your test to fail first to see sort of what you're getting back, and then update them. You don't want to, but one thing that I should warn you about is like you don't just want to look at what was expected and just type, what was received and just type it as your expectation. You want to make sure that you do some thinking around that. I do like to see this failing, see what I received first, and then analyze if that's the right thing, and then I update the test. So to be 2, if we have an empty array, let's call this input 2. The length of that we expect it to be, oh, actually here, let's just use input 1.length. Here we can do 0. Or we could also use input 1.length. That is that. There, let's do a really long array. Do you remember? I think Jonathan was showing us how to create an array. An empty array, a long but empty array. How can we create a long but empty array? Do you remember? Anyone remembers what Jonathan shared? Yep.
Yeah, we do equals new array, and parentheses, you give the number. And if you want to fill it with something, you do dot fill with
Okay.
what you are.
That's correct. So let's do a very long one, 1,000. An array of 1,000 empty slots. If we do input 3 length to be, let's do 500. Would it be 500? Let's take a look. Oh, I asked it to expect 500, it received 1,000. That's because this array is 1,000 in length. It's just empty, but it's 1,000 in length. And we're using here, instead of the curly brackets, square brackets, we're using the array constructor. And so on. Questions about this one? Your thoughts? For empty array. Cool, let's do the last one. Returns an array where each element is squared. Any ideas how to do this one? Hugh Paul.
I was looking through the documentation and I saw something. It was doing like a test with like a for loop.
Oh, it was doing a test with a for loop.
Yeah, the one that says like it's like yeah, I don't know if it's the exact one, but it says like adding positive numbers is not 0. Yeah, that one.
This one.
But like, can we use the same method to check each element of the array?
Yes, we can use the same method. We can certainly do a loop and expect inside of it, like they're doing here. However, we don't need to.
Okay.
We could use, yes, I mean,
We can use the equal.
we could use the to equal instead of the to be. Let's take a look at that. So we can say expect square array 1 and 2, for instance, to equal the square version of that, which is 1 and 4. It seems to have missing parentheses there. So we can use to equal. Remember, the difference between to equal and to be. To equal will loop over internally over the elements, and it will compare each one. If it's an object, it will compare the keys and the values, etc. And let's try to run this. It passes. Just so that we verify that, let's have it failing, expecting some element that's not there. Let's take a look. Fail. Look at what this is also cool. It shows you the difference. So, oh, this is interesting. Yeah, expected -1, received +0. This is deep quality. Well, this one, I think this must have changed recently. I don't remember it showing it like this, but we can see here the difference, which is interesting. We see that the I guess expected 1 less, but I didn't remember what the +1 will mean there. Anyway, here we see that it didn't expect this 6. It expected 1 and 4, but it didn't expect this 6 here. So let's remove that there. And if we run again, we should pass that test. Cool, let's do a few other examples. Square array, start 2, 4, 6, 4, 16, and 36. If my math is correct. Cool. What should it be for an empty array?
Empty array as well.
Empty array as well. Empty array as well. Cool. So, questions, thoughts about it? If you think about it, this is when you are doing lead code, when you're doing code wars, when you're doing HackerRank. This is what they write for testing that your function passes or not. And then it let you know which one it passed, which one it didn't pass. Cool. So this concludes our lesson on unit testing. This is whenever you're having functions that maybe, and I have seen this, I've seen some of you have like utility functions in your React or your Express, maybe about formatting text. You can unit test those in this fashion, expecting the values, expecting your function to return the value you want. Excuse me. And once we do like React testing, we're still going to be using describe and test, and we're just going to say, I see your hand. That was, we're just going to say, well, expect this button to be in the screen. Expect this thing to pop up when we click this button, and so on. Douglas, you had a question or a comment?
Do we need to worry about making sure that our test.js files are covered by our git ignore, or is that something that it's fine if it gets pushed?
Good question. Yeah, so your test should be pushed. Your test files should be kept tracked by Git. Yeah. As another standard is when you have, this is just because we have one file, but once you have thousands of them, a standard is you create a folder called __ tests. I don't know if it's singular or plural. Let me check here. I think you didn't put it here. I think it's __ test, and we put our file there. If let's try this out. Tester should, yeah, it still picks it up. Ooh, we have some failing. Oh, I guess the require now change, but this is standard when having this __ test test folder, and inside of there having your test there. Actually, I'm gonna do that. I'm just gonna update this here. The import or the require is functions npm. Yep, and then my tests are passing again. So once you have more test files, then you keep them in the __ test. Amin and then Joy.
Okay, if you have more than one file and you run npm test, it will like execute all the files?
Good question. Yes, it will execute all your test files. Joy.
When you execute npm test and then it gives you a time at the bottom after snapshots, what accounts for the difference between that time and the time it calculates everything? Because after everything it says like it ran in 1 millisecond, 2 milliseconds. So where does the other time come from?
That's a good question. I don't have a good answer for, but let's take a look at what you see here. So this just will tell you how long your test took to run. Here, the multiplied two numbers took 4 milliseconds, 1 millisecond, 1 millisecond. But the total time was 1.1 seconds. It took 1.1 seconds to run all our tests. So Joy, what you're saying is like these milliseconds don't add up to 1 second. So what is taking the rest of the time? Is that correct? Is that your question?
Yes.
They add up.
Yeah, Cameron.
I think they add up. 11 milliseconds is 1.1 seconds, right?
Oh, that's correct. Yeah, because a millisecond, 1,000 milliseconds. No. Okay, no, they don't add up because 1,000 milliseconds is 1 second. And these are just 4 milliseconds, so no, they don't add up. 11 milliseconds are still 11 milliseconds. Still missing 989.
Yeah, I think like each time is when you execute just the test like expect something, and the total one is like running the file, exporting, importing the functions and all that.
It might be. I can't confirm. That might be a good question for Google. Chuck and then Douglas.
My question is more so like about the different test suites. Is it better to use Jest or Mocha? Like I've been doing a little bit of research on both to see which one is better.
Both are good. I have a personal affinity towards Jest, just because with Mocha, so Mocha is another framework. Let's see, Mocha testing. Mocha JS, all right, I guess. So Mocha was created for like asynchronous testing code, like functions that return promises, and so on. The problem with Mocha, I think, is the assertion library. No, but I think it is the same. Oh yeah, so you see here that they are importing assert. Assert is like the expect in Jest. But they're doing it here with the native one, which is assert. This assert comes from Node. Node has a built-in one, but then it has some limited matchers. So, for instance, I don't think it has to be. Oh, actually, it does has equal. Oh, does it have equal? No, I think it doesn't have the two equal the same way. It doesn't have like to be defined, to be undefined. To do that with Mocha, you need another thing called chai that will provide those matchers, the assertion library. So the need for two separate things is basically what I think makes me go with Jest, because Jest is more rounded. It has everything that I need in one. So I'll recommend Jest over Mocha, for instance. But there's no yeah, you can go with whatever you want. Douglas, you had a question, or I saw your hand.
Just a quick comment here. Let me share my screen because maybe I can't.
Let me stop sharing mine.
Oh, that's right.
Go ahead.
Let's see if I can find it again. Those are all finders. Code function test. There we go. I don't know if we can see my. Oh, did I lose control of it? There it is. I don't know if we can. Oh, this is it's the wrong one. This is my. I'm sharing the wrong one. Hold on one second. I'm sorry. Is this it? Maybe this is. I've got too many open.
I think we can see VS Code now.
All right, so, but is this the? No, that's my other app that I was running. I've just got too much running right now. I'm sorry. What I was going to try to get at was the fact that I'm running from an external hard drive, and it slows down.
The number of the time.
Exactly. This might be what I'm looking for.
Yeah.
No, that's not it either.
Yeah, it's gonna slow it down because it has to go. Your laptop probably has an SSD, which is where your files are kept, or the SSDs are rather new. If you have an external hard drive, it's a spinning drive, right? Well, you can hear it. That is just generally slower, so that's why it takes longer.
Yeah, no, I figured, but it was that was, I guess, in where that processing time comes from, because it's going to the external drive.
Yep.
To find that information, I guess.
That's correct. It has to load it from there. Oh, I have. Well, I used to have that same drive. It's very good for video.
Yeah.
Yeah. So it's gonna take longer because it's a spinning drive, and it just takes longer to go there and get your files. Those files have to be loaded in memory and all that. Other questions or thoughts? Final. Yep. Cameron.
Kind of question. I was trying to see if MS could possibly mean something different, but I can't find too much information. But I found something called Mark Sweep. It's like an algorithm.
I don't think. I think it just stands for milliseconds.
Okay, cool.
Yeah.
But does that have anything to do with Jest, Mark sweeping?
I don't think so. I've never heard of that.
Okay. All right.
Yeah. Okay. Cool. Thank you everyone for your time. Take this 15 minutes to go to the lab and work on some unit testing, some extra unit testing there. This is going to be, once we look at React testing, that's just going to build on top of what we saw today, as I said earlier. Yeah, go to the lesson of today and work on the unit testing labs there. In the afternoon, you're gonna be working on your capstone. I want all of you to have your sprint planning meeting today. So I want all of you to get into your teams and come up with 3 bullet points of the things that you want to get accomplished for this sprint. What are and describe those 3 things in terms of the users, saying user will be allowed to log in, or user will be able to add a new note, user will be able to delete a to-do, etc. So in that sprint planning meeting that I want you to have today, just think about those 3 things, and in terms of the user perspective. And I'm gonna share a Google Doc later on, where I want you to put those 3 things. Every team is gonna have like its own space, and I want you to put those 3 things that you want to set by the end of your sprint planning meeting. What are the 3 things that you want to accomplish? Then at the end of the sprint on Wednesday, we can review, we can talk about it, and so on. But I want to get you all in that mindset of starting to think, or sort of be envision what you want to do, and then try to commit to that. That is just good sprint planning. So that is it. I am here. Anyone has any questions? Remember, don't go and practice a little bit more unit testing. To submit, just make a pull request to the repo. Same way, you don't have to submit on Canvas. You don't have to complete it by today, but you should still practice that. Yes, Douglas.
I'm not certain if it was set up. I'm going to probably use the time regardless. But are we meeting tomorrow, or is
good question? Good question. Tomorrow is Easter Sunday. Is this what it's called? Generally, that's not a pursuit holiday where we take time off. But given the current circumstances, given that a lot of our community is Christian, Pursuit has decided to take that time off for us to recharge, and for for Christians to reflect and take that day as it is intended by their religious practice. And so yeah, we don't have class tomorrow. You still, yeah, that's it. We're not meeting tomorrow. We'll see. We'll get back on Monday. Good question. Yeah, so I'll be here, practice. I'll send the doc for the sprint goals. And yeah, if you need any help, reach out. I think I'm meeting with some of you for mock technical interviewing later on. So yeah, keep me posted. Thank you everyone for coming. I'll be here.